Welcome to tonight's rabbit hole. Hang on to your shorts. Hey, what the hell? I can't hear it. I could hear it before. All right, we'll try that again. I'm Joe Slick, your host, and I have with me Canuck this evening, and we're going to talk some goodies tonight. I'll put it in chat what we're going to talk about. The western edge of the Pacific. No, the eastern side. It's the eastern side. Shoot, howdy. I'm going to have to fix the name. The eastern edge of the Pacific rise. Oh, and the danger that Mount Rainier brings to the planet. That's the title for tonight. Yes, we're going to talk about South America, Central America, and Mexico. There's a similarity between them all. And you've been eating the red candy? I don't know. Is it what's been red? No? We're here. Say hello, Canuck.
Hello, everybody.
Yeah. Here we go. Yeah. Turn it up. Yeah. Not yet. Take control. And bold. Mm-hmm. All right, they get to see it. I'm working on it, Eden. Yeah. Yeah, welcome to the rabbit hole. Say hello, Canuck.
Hello, everybody.
Yeah. Yeah, tonight is tonight. I don't know. I hope it goes good. We've been maybe over prepared, and we both kind of went in different directions, but it's about the same subject matter. Um, Basically, what we've been doing, we had an interlude with the Nankai Trough. Indirectly, it is related, but I'll have to fix the title on this. It's the eastern side of things, not the western side. But interesting. We're going to start like way back in time, and then we're going to build to where we're at currently. We've been talking about plate tectonics. Oh, I don't know, about 10, 12 weeks now, and on and off, and it's really, really starting to hone in and dial in, and the understanding is there on how the plates move, and the fact that they're moving is evidenced by volcanic activity as well as earthquakes. And these earthquakes are happening along electromagnetic lineaments as well as the edges of the plate and the interplate. And when it happens on the interplate, you're going to learn a little something tonight, and why they're happening on the interplates. It's a supposition we're putting out that there are strata or levels of the earth. It's not just all dirt, but there's different kinds of rocks at certain levels, and they each have different ages. And when you get a thrust fold, it's when one group of rocks rises up and goes over the other rocks, or gets pushed on it, or they both crash into each other, rise up into the air, or you get uh, 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 cracks in the land as the land spreads apart and rocks rise up and create lava plugs, magma plugs, and stuff like that. Um, so magma has a lot to do with what's going on, but the creation of the current visual of the earth is what we're after, and how these things are put together, and the earthquakes again are only evidence that these types of strata and combinations of igneous provinces, which are provinces out in the ocean that come on shore and combine in a created creation, created terrains, show creating what we have today. Also, we'll talk about the big talk about Rainier, and I'm not going to say much about it. You'll have to. We have a spot we're gonna put it in, so just listen to it. Interesting turn of events that are happening with Rainier. Very, very, very interesting, to say the least. And it's tied to other areas on the planet. I won't go any further than that. And it should tell us something. Tell us that Rainier is connected to 7+ earthquakes. Yeah. So hang in there, everybody. So Canuck, starting off with the overview of the plate tectonics and the way things work, where would you like to start this evening so people can understand what it is that you have to bring about the three areas of primarily Mexico? You say you have. Go ahead.
Yeah, well, I'll probably do a review first. So,
Sure.
our previous episodes before we talked about Nankai Trough last, we were in the Caribbean and Central America and the Panama Plate, and then we did the North Andes Plate in South America. So we're moving back to the various blocks that are in Mexico now. That's what we're going to
Right.
start doing tonight. But it's going to be quite the process because there's a lot going on in Mexico.
Yes, there is.
More than just cartels and all that.
Yeah, we seen this morning on the morning report. Kalima's in play right now. Also, is a little volcano that happened in the 40s and early 50s. That's in play right now. Very interesting. And I don't know which block they're on, but you'll get us there.
Yeah, explain it.
Yeah.
Acting up, which is the boundary between the block we talked about the other time, the shortest block.
Mm-hmm.
The one we're going to start with tonight, the Maya block.
Oh, the Maya block. Okay.
Yeah.
So do you have an image ready for us? All right.
Yeah, I'm going to put the wiki in for it because I actually have a wiki for this one. It's like super detailed.
Yeah. Dun, 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 dun.
Oh, I got to copy it again because it's not going over.
Yeah, crazy, right?
I don't know. Sometimes it won't copy. There.
You know, as you're trying to do that, I figured out where the Izanagi plate was. I never knew where the heck it was. It's like you kept talking about it. I'm like, where the hell is that thing?
It's way over under
it's
Japan
side of things, yeah. The Maya block is known as the Maya terrain. The Yucatan block or the Yucatan Chiapas block is a physiographic geomorphic region and tectonic or cluster block in the southernmost portion of the North American plate. Wow. It's part of the North American plate here. So we do have an image.
Basically it's Yucatan to Chiapas.
Yeah, it looks like it's Yucatan to Chiapas. So there's one that shows a bunch of them. I think that's the one I'll choose. Number 3 to share with people. Share my screen, window, bing. There we go. The Maya block here is a Yucatan, right? There's 2 kilometers isobath, right? Offshore Campeche Bank, right? And then you have Mexico, right? The Gulf of America, the Oaxaca stuff, Coahuila and the Sabine and Suwannee and the Carolina, Wachita salient, all these little pieces of Peri-Gondwana terrains. What does Peri mean? Peri? Is that prior to Gondwana or with Gondwana?
I think it's like in between.
Okay, in between.
So stuff that was in between Gondwana and Laurentia, which
that's what I thought too. Yeah.
Which is basically old.
Prior. Okay.
Ancient Africa. The names get annoying.
Yeah.
Like I don't know why they can't make it simple, but they got to change all the names.
Yeah.
That's what it is.
Yeah, I'm trying to get to the place where, basically, this is Pangea. This little red line, this is that block prior to Pangea. So that's part of the Carolina Sudi Sabine right there. And I think Maya is part of that as well.
Yeah, because it talks about it in here that they think it's actually could be connected all the way to Louisiana.
Yeah, that's what I read today too. That it's part of it's all these yellow parts of Mexico. This is old Mexico. Home front due to shit. New missiles. It never stops. These cocksuckers.
I would assume it's the Houthis, but who knows? Yeah,
phone areas Samaria and Jerusalem. you know what these stupid ass Houthis going to do? They're going to hit the Temple Mount one time, and Israel's going to go ape crap all over the freaking place.
Or it's going to hit them on and blow it up.
Yeah.
Hey, over there.
Is that where the black square is? In Amman?
No, Amman is Jordan.
Jordan, okay.
Right,
what about the black square is in Saudi Arabia, right?
Because when Iran shoots, it comes over there, and it also comes over Syria. So my theory is that both Damascus and Amman, because there's actually prophecies that they get taken out and
taken out, yeah.
And nobody can live in either place, Damascus or Amman, Jordan.
Really?
Which used to be called Rabbah before.
Yeah.
And now
well, I know the one about the one that's in Iraq. Yeah.
The Ammonites.
Yeah, the Ammonites. Yeah, they're definitely Jordan. Yeah.
Yeah. So it's pretty interesting because there's actually prophecy.
They go all the way up to the mountains up there, the Hittites.
Where both Damascus and Amman, Jordan get burned up, and you can't live in them anymore.
You can't live in them anymore. Yeah. Unfortunately, right?
Like they've been burned up other times, but people came back and rebuilt it. But.
So Tel Aviv is on the chopping block. Jerusalem is on the chopping block. Ashdod is on the chopping block right now. Unfortunately, these sons of bitches out there in their religious war against another group of people.
Well, I assume it's the Houthis that are shooting it right now.
I think it is the Houthis. And we've got two major aircraft carriers down there. I think we're going to take the some bitches out. I really believe it. Because they shot 2 ships, sank one of them. I don't know if the other one sank.
Yeah, I think both did now.
Both did now? Yeah. Loss of life, too. Yeah.
Because there's videos of one for sure, but I think
yeah.
Today.
Yeah, I didn't get to see today because I was super busy. Anyway.
One of them was a food carrier, so I don't know why they just would have taken all the food off it first.
I think it's they did it just because they could. They just did it because it's opportune time to do it. Yeah. Again, I'm gonna say it again, sons of bitches.
Well, we got to get back to North America.
Yeah, get back to North America, will you?
Get back to Mexico.
We got 15, 20 minutes before we know where it's coming. All right, so hit it.
Yeah. So now back to this. I'm just going to read it off more. It talks about a bunch of stuff, faults that we talked about in the last show too. So.
Right.
Yeah, so I'm just going to read a bunch of it here. The block is commonly delimited by the continental margin in the Gulf of Mexico to the north, in the Caribbean Sea to the east, and in the Pacific Ocean to the southwest, and farther by the Motagua-Polachic faults. Now, that's right where the quakes in Guatemala are happening now by Guatemala City. That's where the Motagua-Polachic fault is.
That's right here where the arrow is, where I have right now on screen, right in here, okay? These are the... Go ahead.
North American plate boundary.
Yeah, that's the North American plate boundary right there. Right? Here's Salvador, here's Guatemala. So these quakes are happening right by Guatemala City, right by Fuego, right by Santa Guido, Santa Maria volcanoes, Pacaya volcano, which erupted, 2 or 3 years ago. So right in that area.
So that's where it's quaking right now, is on that.
Oh, here they're already coming.
Yeah.
Yeah.
And so those quakes right now are at the bottom of the Maya block, which is kind of weird that it started doing it there the night before we were going to talk about this, but that's just how it works.
Go ahead. Hey, we're always on key.
It's been quiet there, and I've been watching that spot, expecting it to do it. So
you're catching them too, yeah.
So the Motagua-Polachic fault divide the Maya block from the Chortis block, which we talked about the Chortis block, one of our other episodes, while the Isthmus of Tehuantepec divides it from the Waukeya block. Well, it's like Oaxaca. Yeah, Oaxaca with Kia on the end.
Yeah. Mm-hmm.
Waukeia, I guess it is. Block.
Wakatia, or whatever. Yeah.
Uh,
I think I put that one up there before.
Mares,
Yeah.
Pocatico, and Waukeia block.
Wachita. Yeah.
Microcontinent. The block's precise sub-area limits are not widely agreed upon. So the basement, they're not sure how old it is.
Right.
In contrast to its relatively exact submarine borders. Furthermore, it has been recently suggested that the block's western extreme may rather extend past the Isthmus of Tehuantepec along the Gulf of Mexico and into Louisiana. So they're saying there may be a connection. So that's pretty interesting.
It's basically the Central Pangean Mountains. That's kind of what it is right here on screen. All that brown right there, that's basically the area we're talking about, right? So it's the between Pangaea and South America and Africa. Here is Laurentia, and here's the Gulf, right here where the P and the A is. So it's where this brown area is. It extends pretty far, what he's talking about. So all the way up through Florida and out. So that's the group of these kinds of rocks.
So basically, Iceland is connected to Mexico.
Yeah. We've seen it, right?
Yeah.
Excuse me. Let me find that map again. Well, what the hell? Okay, right up here. Yeah. All the way up. Yeah. All the way. And the movement of the plates in all this area, that's kind of what he's talking about. So.
Yeah. So the next thing here talks about the physical geography itself. So it talks about the different mountains. So I'm just going to read that off. A broad arcing fold belt of morphological distinct mountain ranges separated by deep fault-controlled canyons and occasional broad alluvial valleys extends along the south-southeasterly limit of the block. The most prominent of said mountain ranges are the northern Chiapas Mountains and the Sierra Madre de Chiapas in Mexico.
Right.
And Cuchamatons, that's like the name, Chama, Santa Cruz, and Lacandon ranges in Guatemala, and the Maya Mountains in Belize. So that's where they got the name of the block. It's after those mountains and the Mayans, of course, that were based there a while ago. Now the next section talks about the karstlands. The most extensive karstlands of the North American continent extend northwards from the block's southern extreme. The block's most prominent karstic landform is the Yucatan platform to its north. Relatively less prominent karstic formations occur in the block's southern portion, including an unnamed formation in northwestern Peyton to northeast Belize, the Belize Barrier Reef, and the Lacandon Range, the Cuchamatons, however they say, range, and various formations to the north and south of the Maya Mountains. Now, the next section talks about the coast. The most prominent topographic features of the block's Caribbean coast are extensive seagrass beds and coral reefs, with the Belize Barrier Reef forming a notable example of the latter. Its Pacific coast, in contrast, is predominated by extensive mangrove forests. I guess there's a lot of mangroves in there.
I don't even know. Yeah. I think it's dense forestry, right?
Yeah.
Mangroves. Okay. With the roots that are exposed a little bit, I think that's what mangroves are.
Yeah. So the next section talks about the human side of it. The terrestrial portion of the block encompasses all 6 districts of Belize, 5 northerly departments of Guatemala. I'm not going to say all their names.
Right.
And 5 southeasterly states of Mexico. So Chiapas, Tabasco, Campeche, Yucatan, and Quintana.
That's all the Yucatan Peninsula. Yeah.
Its submarine portion encompasses the continental shelf, which abuts to the coastal districts. Now it talks about the crust here next, which is interesting. Mean thickness of the continental crust constituting the block increases southwards, ranging from 20 to 25 kilometers, 12 to 16 miles, in the northern Yucatan Peninsula, to 30 to 40 kilometers, 19 to 25 miles, in the peninsula south. So it's thinner in the north, thicker in the south.
Interesting.
So that's pretty interesting. The crust block's crystalline basement is composed mainly of Silurian, Triassic, Metamorphic, and igneous rocks, and is exposed in at least 5 formations, namely the Mixtequita Massif, Chiapas Massif, Cucumatan, its dome, Tucaru, Talamon, and the Maya Mountains. Elsewhere, the basement is overlain by thick sedimentary cover of Upper Paleozoic class and carbonates, Upper Jurassic continental red beds, and Cretaceous Eocene carbonates and evaporites. So it's a whole schmozzle of all sorts of crazy stuff. It has been suggested that the block's continental basement is stretched since its sedimentary cover reaches a thickness of up to 5 kilometers. This being considered impossible on an unstretched basement at isostatic equilibrium.
Hey, Lori Baldwin subscribed. How you doing, Lori?
Then it breaks it into the provinces, the basins, and the faults. The block is thought to fully or partially incorporate between 2 and 13 geological provinces. So that's
nice to see you.
Depending on which study that you're looking at, I guess. The block is believed to fully or partially comprehend some 4 or 5 sedimentary basins. A number of faults or fault zones have been identified within the block, the most prominent of which include various boundary faults abutting the Maya Mountains, various offshore faults east of the Yucatan Peninsula, Belize, the Tacul Fault, the Mount Paso faults, and the Rio Hondo faults, which I haven't even looked up anything on them, but at least it's given us what their name.
Yeah, Rio Hondo sounds familiar. I think we've covered it before.
Yeah. The block is thought to experience significant counterclockwise rotation. So see here.
Agreed. Yeah.
And a northwest down tilt, which gradually lowers the northern portion of the Yucatan platform, thereby lifting its southern extreme in the Maya Mountains. It is nonetheless tectonically rigid or stable, experiencing an absolute west-southwest motion of 1.8 centimeters, 0.71 inches per year. So it's still going like the same way as what the North American plate is.
Correct. So this on the map here, what we're seeing on screen, this here is being turned. It's being turned like this. Let me start this. So it's being turned like this, and it's, I don't know, why is it not showing it? Damn it. So it's turning it like this, in on itself. Okay, so this block here, the Ouachita, or the mountains that we're talking about are right here on this part of Belize and part of Guatemala. All right, so these sets are higher than it is here. So the elevation is higher here than in here, and you can see the extent of the erosion. Also, as the water or the ocean rose, this part of it sank because it was all linked. So all of this around the Gulf of America was straighter and that's what this image is showing. Is showing how it's bent, and this is just one block, the Mayan block. Part of Mexico is controlled by these faults that go offshore, and you can see just the topography on this map here. These faults, the Cayman Islands. Here's the 7.6 that happened on February. It leads right into these mountains and into Guatemala, and then up into Chiapas. So that's why we're talking right now. We're talking about the edge of this, the Caribbean plate, and what parts of it in this region are related to these faults here, and the topography and the history, the age of the rocks, and why it's connected to the greater extent of the Gulf of America, because it all used to be flat or straightened out, and as the push up of South America pushing north, and the Caribbean plate pushing north, it has moved this southern block of Mexico, bent it in on itself, and it's now going almost the same direction as the Caribbean plate and North America. I think I summarized it well enough.
Yeah, so now I'm just going to keep reading here. Central America, including the southern portion of the Maya block, is very well known and characterized by numerous medium-sized earthquakes, preceded and followed by damaging shocks, with the Middle America Trench in the Pacific being the main source of such quakes. Of 33 earthquakes of magnitude greater than 7 in Central America during 1900 to 1993, the epicenters of at least 2 of these were located within the block in its southwestern quadrant, which is basically Guatemala City. Through a further 9 were located near it in the Motagua-Polochit Faults, or the portion of the Middle America Trench bordering the block. So basically the southwest corner of the Maya block gets hit with a lot of big earthquakes.
Right. So
sevens, especially.
I want to read this history of the Pre-Cenozoic and the Cenozoic for you. Middle America, including the Maya block, is thought to have taken shape sometime after 170 million years ago. Its formation is thought to have involved the complex movement of the various crustal blocks and terrains between the 2 pre-existing continental masses, North and South America. Details of the pre-Cenozoic portion of the process, 170 to 67 million years ago, however, are not widely agreed upon. Nonetheless, it has been proposed that the block formed before during the opening of the Lepidus Ocean. And if we're looking up the Lepidus Ocean and we go into a deal, these are old, all right? Lepidus Ocean right here. Here's Laurentia. Here's Amazonia and all that stuff. Okay, so prior to this, that's what they're talking about.
Yeah, Lepidus Ocean was the one for the Atlantic. Yeah. And it was like a little thin ocean.
Right.
It basically goes right through where I am, because if you look up Lepidus Suture Zone, it basically goes all the way from where we're talking about, southern Mexico, basically, all the way right up the east coast, Iceland.
And it's basically saying what I said earlier. It together with the Wakakia, the Suwannee, and the Carolina blocks are thought to have been constituted as the Gondwana terrain on the continent's western, northwestern, northern, and eastern edge during the Appalachia-Caledonian or Ouachita Marathon Appalachian orogeny. That is, during the formation of Pangea, from the collision of Gondwana and Laurentia. So Laurentia in the north, Gondwana in the south, smacking up into each other, created all these rocks.
Yeah. That's why the terrain I'm on is from Gondwana, because it's from the lava that came from the supervolcanoes.
Yeah, well, that's you're getting way back in time, and that had to do with the Campi there, which is all part of this. This is well after that. event.
Yeah.
So
Because
as well
the
after.
super volcanoes by me is when Pangea was forming together.
Yeah, they were coming together. Now we're talking about them splitting. So they were together like 200 million years, and then
350.
yeah, they're moving apart now. So it is thought to have been displaced away from Laurentia Craton by a clockwise rotation, translation, and anti-clockwise rotation during the Middle Jurassic opening of the Gulf of America and the subsequent northwesterly drift of North America away from Pangea. In the Cenozoic era, 66 million years ago until today, geologic history in the Middle America, including that of the Maya block, are relatively more widely agreed upon now.
So that was after
Now, the argument is prior. There are two theories talking about how Pangea and Laurentia smacked up against each other and where they smacked up against. The real argument is what latitude and longitude did they smack? They smacked when they were down further, well down below at the equator, or actually at the South Pole, and split apart. And as they split apart, they migrated north and then also eastward, along with the creation of the Pacific Plate and the dying of the Farallon Plate and all the other ones. Cenozoic, details of the Cenozoic up to 66 million years ago in Middle America, including that of the Maya block, are relatively more widely agreed upon. The broad strokes, the shortest block is thought to have reached its present day position at least 20 million years ago. The northern eastern coast of the block are not thought to have been fully subaerially exposed until 5 to 2 million years ago. So they were hidden underneath. Okay. So they came up, they rose up as the plates crunched each other. The uplift occurred and exposing a lot of these. The block's coastlines, which were initially more expansive than it is at present day, ones are thought to have reached modern dimensions due to the rising of sea levels some 11 to 8,000 years ago. Okay.
So it's ongoing.
If you've listened to us over the last year, and you've listened to Nick Zentner over the last year, the idea that the Cascades rose, 30 million years ago, it blew his doors when they didn't, about 1 to 3 million years ago. They're rolling hills, yes, but they didn't get their heights until very recent in time, geologically speaking, that is. You're hearing that here as well, that something is occurring less than 16 million years ago. I say 16 million years ago because that's going to be a theme that's going to keep coming up and up and up. That's initially, that's the creation of the basin and range in North America. Initially, that's the creation of the rift zone that cuts into a North America. Interesting that the older part is in the south, the younger part's in the north. So what does that tell you? It's trying to split North America in half from the south. But anyway, that's another story. We're going to go there.
Well, it's going to kind of explain that in the timeline chart down here.
Yeah.
It's at the bottom where it talks about how this block formed, which we're
Right.
going to go over because it's kind of fun. So it makes sense because it has a bunch of stuff in there. So it's right down at the bottom of this page. It has the timeline for how it formed.
Okay.
Yeah.
Well, timeline here, yeah.
It's starting at 1.6 billion.
Right.
To 910.
910. Calamine-Tonin block. The first geologic period of the Neoproterozoic era lasted 1,720 million years. Instead of being based stratigraphically, these dates are defined by ISIS based on radiometric chronometry. Okay.
Yeah. So.
And then the Middle Jurassic.
Yeah.
That's when Pangea rifting starts, right? The Maya block formation starts. Again, the creation of the block the mountains,
Yeah.
right? The rocks being put together through volcanic and creation of all that all started 1.6 billion years ago, right? So now the Pangea started rifting apart between 240 and 200 million years ago.
Yeah.
There's a huge events that are happening prior to that rift, which is one of the greatest life-killing events that took place, and that happened around 252. And I think like 95% of all life was wiped out, including that what was in the seas. And that has to do with those super volcanoes up in that red line I showed you earlier. All along that red line just exploded. And we call it the camp, the Central Atlantic, explosion. The Atlantic started to form right after all this. So 165, the Middle Jurassic, the Gulf of Mexico, seafloor spreading started. Early Cretaceous, 144 million years ago, the Caribbean seafloor spreading started. So you can hear spreading, right? What happens? That means two pieces of land are moving apart, right? And 120 is the tortoise block subduction into southwestern Mexico stops. At that same time period, that's when the Sierra Nevadas were created. They were being accreted on by North America about 120 to 100 million years ago. So not Shasta, but it was prior to Shasta. Shasta wasn't even a thought of yet. That's super young. So the Sierra Nevadas, the Death Valley, the creation of Death Valley, that's an interesting story, which we won't go into today because it's north of what we're talking about down here. We'll get there. The Panamint Valley, also the Owens Valley. Very interesting. Nevada is really far out. There was a meteor that struck there. And there's thoughts that it started it all. It was bigger than the 66 million years ago meteor. So, and that happened, oh my gosh, a long time ago. But anyway, back to us. 72 million years of late Cretaceous. The Greater Antilles are collision of the Maya block starts. So that's the
side of the Caribbean plate.
That's the well, I'd say the eastern side, but some would say the western. It's the eastern side, right? Because it's east of us.
Yeah.
Okay, cool.
Well, that's west of it at that time. If it was
you're right. Also, the seas rise and lower during these time periods too. Late Cretaceous, 63 million years ago, the tortoise block continues, Maya block starts. That has the 66, the one of the proposed three meteors that hit the Earth, killing all the dinosaurs and everything else. That is the fifth extinction event. Okay. Chicxulub 66 Pliocene. Asteroid impact Maya block occurs. Eocene 49 million years ago. Cayman Trough rifting starts. The Cayman Trough.
Same time Celestia was.
Right here. The Cayman Trough. Cayman right here. This trough starts to create. Right? Shortly after what? The big event that took place right there. Right? At the same time, what's happening in the Pacific Northwest? It's accreting the last piece of landmass right up in here. That was out there, igneous province. That some believe it was created by the volcano at Yellowstone, which is still offshore, by the way, at this time period. It's getting ready to come on shore. and burn itself through the continent. So just to put everything in context is what we're trying to do here.
Yeah, so around like 50 million.
Yeah, 50 million years ago, yeah. The Cayman Trough starts to slow down because the eastern part of the Caribbean is moving into it. So it's no longer spreading. It's being pushed. And 22 million years ago, Farallon plate rifting starts. Why is that important?
Well, they're saying it's breaking up into the other plates that we have.
Mm-hmm. And between 49 and 22, Baja is created. 40 million years ago, 400 miles. Just think of that. It's gone 400 miles from where it was joined to Mexico.
Ripping a piece off it.
Right, because the rift went underneath. It went into the land and pulled it off and shifted north. And at that same time period, several major volcanoes were going off. I think 33 was that one in Utah, right? That
Walla.
Walla. Yeah, Walla Walla.
Wawa.
Yeah.
Wawa Springs.
Yeah, Wawa Springs, yeah. That thing blew up. Now we're getting to 2022. Fairline's doing 22. Miocene Cocos plate subduction into the Tortoise Block starts. That's the western side of Guatemala. I believe that's the Tortoise Block. I just want to make sure. Trying to put things into context for you guys.
Well, yeah, Tortoise and Maya is basically the.
See, all this is the Tortoise Block, okay?
Yeah.
This whole thing. So this rift right here.
Top of Costa Rica.
Yeah. So, and the Maya block is up here.
Yeah.
Okay.
Starting in Mexico, but also including
right
the northern half.
So this rift begins. Let me just close that. 10 million years ago, the Miocene, super fast spreading. The East Pacific Rise starts and stops. I don't think it stopped, but hey, it's moving.
Super fast spreading.
Yeah.
Because it's changed at different
rates. Yeah, because it can't move as fast because it has the North American plate, the Caribbean plate pushing up against it, which is the Cocos plate as well. That's the edge of it. Yeah. And that's this is not being able to show it, but it's basically out here. And then it kind of rides up right between Baja here. See, Baja used to be down here. It's moved there for 400 miles. Yeah, interesting. And then Panamanian Isthmus closure starts and stops.
Which
we talked about that's right down here.
So it's the most recent one. But
yeah.
Connected everything to.
Right, which is also part of Colombia down here. That's why this area gets rocked huge, because it's a little plate. Down here is the Galapagos, which you can't see, just one little island of them. There's much of these volcanoes are created then by this rifting or this subduction that's taking place. Massive amount of volcanoes. There's no volcanoes really in the isthmus of Panama, except for over here, and I think over here, but in the central part is none, because of a triple junction that has disappeared, and this thought or the theory that there's a slab window right here as well, meaning there's a break in the plate that has no spot where the magma would burn off and thus create volcanoes. So that's why that's no volcanoes there. But the volcanoes do start here in Costa Rica and burn all the way up through Mexico, all the way up to Canada and Alaska. So interesting to say. So
So now I'm going to put in there a map of the next two blocks.
Okay.
Michoacan and
The Michoacan? Okay. Struck asteroid there, yeah. Research gate. It's going to verify that I'm human.
Yeah.
It says, okay. Here's the Jalisco block and the Michoacan block. Okay. I'm going to show you on the map just about where we're at. Here's Colima right here in the middle. Right? Here's Jalisco. Here's Michoacan. The Sierra Madre Occidental, that's the mountain creation part of Mexico, right? So on the map, up here, we've got a lot of volcanoes on this map. I'll just take those off. Say new. All right. Jalisco's right here. Michoacan's right here. And Colima's right here. So Jalisco, Colima, Michoacan, Guanajuato, Morelia, Mexico City, Guerrero, right? Oaxaca, Chiapas, Veracruz, Potasi's up there. Campeche, we're talking about already. Belize, all right? Here's Guatemala.
They say the Maya block was not, it was a separate thing. It wasn't.
Separate, yes.
Yeah, because the other two blocks are the Guerrero terrain that smashed
Right.
in.
Right.
And,
So,
but they still say they're about 170 to 75 is when they'll start
Right.
smashing.
So I'm going to draw on this map here to kind of tell you basically what North America, old North America is.
Yeah.
All right.
And they're saying Sonora and
Everything to the right is North America. Everything to the left is accreted plains, terrains. Okay. Now, if you've been with us for 5 years, you learned about the crazy Eocene era up in Washington and Oregon and parts of California. You saw the two different terrains that were accreted, the intermontane and the what was the other one, Kanaki, if you remember. Anyway, the two different terrains that were
Intermontane, I think.
the intermontane and the other one. I forget. There's right, and it's interesting. The 706 line where it comes right down here into Arizona and Mexico, right? I found a map. It showed that. That was wild to see that, and to learn that all of this is igneous province, meaning it's outboard, underwater, and it's slammed up against North America, or North America slammed up against it. And as it did, it bent this section. This section used to be out here. It bent it, and it's continuing to bend it in a counterclockwise rotation. Now, clockwise or counterclockwise rotations are very strange happenings throughout North America. We have one here at Garlock. We have another clockwise rotation up in
Mojave's rotating.
Yeah, Mojave's rotating. Yeah, Mojave's its own block.
The basin and range is.
Yeah. Right. Basin and range. Yeah, it's spreading apart. It's spreading because of the rift that North America went over, which is part of the Farallon, the southern end of the Farallon plate, and the Pacific plate together. Or there might be a whole other plate under there, but they just don't know. That's why it's believed that this is more flat, subducted down here. But you're talking 120, 180 million years ago when this happened. But it happened not where it is now. It happened way down here. And all of this has moved north and continues to. So Mexico was not very big, but all of this is accreted. And what's interesting, the 3 blocks, or the 2 blocks so far we're talking about, the Guerrero block, the Jalisco block, right? So go ahead and continue that. I don't want to interrupt you anymore on those.
Yeah, so I'm just going to put in a couple things that gives information about each one. I'll go from, since I started with Maya, I'll do the next one up and do it.
Okay, the mutual con.
Yeah. So I'll just copy it in here. Because I just did the Google AI thing that gives all the, I asked it to describe it. So I'm going to read off. The Michoacan Plate block is a geological block located in western Mexico, characterized by a counterclockwise rotation relative to North America plate. So it's rotating too. It is part of the larger Guerrero terrain, situated near the Jalisco block. The block's rotation is believed to be related to the oblique convergence of the Cocos Plate relative to North America. So the Cocos Plate is smashing into it and going underneath it.
Yeah.
So it's kind of spinning it, I guess that's what they're saying. Situated in western Mexico, encompassing parts of the state of Michoacan and bordering the Jalisco block. It's part of the Guerrero terrain and is influenced by the subduction of the Cocos Plate and the Rivera Plate beneath the North American Plate. Paleomagnetic studies indicate a counterclockwise rotation of approximately 24 degrees for this block.
Wow, counter?
Yeah, counterclockwise.
Right, wow. So this is rotating this way as well as this Yucatan. So the whole thing is rotating counterclockwise. Wow.
So relationship to other blocks. It's adjacent to the Jalisco block, and the two are separated by the Colima Graben and other tectonic features. So basically where the volcano is.
Right, and a graben is what? It's due to a basin and range, right?
Yeah, where it's like sunk down.
It's spreading apart. Right.
Yeah. Volcanism. The region experiences significant volcanic activity, with the Colima volcanic complex being a prominent feature. Geophysical characteristics. Geophysical studies using gravity and magnetic data reveal distinct boundaries between the Michoacan and the Jalisco blocks and provide insights into the subsurface structures, including the Colima Graben. So that's another, like how they're breaking these blocks up, there's gravity and magnetic anomalies too. So that's
right.
Identifying where the boundaries are between these different blocks. So that's pretty straightforward.
Right.
Now, for the next one, I did the same thing. Jalisco. So
for Jalisco. Okay, cool. I have something to add too with that, so it's good that you've done this. It's in the same publication. So the Sierra Madre Occidental is up here, Jalisco block's here, Michoacan. Now he's going to talk about the Jalisco block. He talked about the Michoacan down here, which borders the Colima volcano, right?
Yeah.
And in the bottom of the Sierra Madres, those volcanoes through there.
Now I got to bring this back up here.
Yeah, volcanic bumper cars, volcanic flooring, welding. Yeah. The welded themselves together. Yeah. Well, when the plates spread apart, we get rifts, right? And upwelling, the thinning of the plate, and these, like what's happening in Hawaii, what's happening in Iceland, what happened in the Pacific Northwest. These cracks, and magma rises up and then plugs the cracks, and lots of plugs, crazy amount of plugs I was looking that up too today. Far out, man. It's interesting. It's far out. We would have 5-6 hours if we just stay on this topic, I think.
Yeah, I got to bring it back up again.
That's all right. That's all right.
Now,
I have a lot of tabs open. I need to close some of them.
I think I closed it by accident.
Yeah, it happens. It happens. Yeah. Yeah, welded tough. Yeah. There you go. Thank you, bud.
Yeah, so it's a Google AI thing for it.
Okay, cool. The Jalisco block refers to a geologic region in western Mexico defined for its specific tectonic boundaries. It is characterized by active volcanism and seismicity due to the location at the intersection of the Riviera Plate and North American Plate. The block is primarily composed of the Puerto Vallarta batholith, an area of granitic and granite. Key features are a Jalisco block situated complex convergent plate boundary where the Riviera and a Cocos Plate subduct beneath the North American Plate. The Riviera Plate, let me show you where that is. It's a little area right here. Nereid is right here. Sinaloa is right here. Durango. Right here. It's a little broken plate out here. It's a microplate. Volcanism seismicity, this area experience frequent earthquakes and volcanic eruptions due to the plate interactions of the associated tectonic stresses. Jalisco block is primarily defined as a Tepic Zolaka rift and the Colima rift. Wow, that's interesting. Both which are active fault systems. Let me see if I can get an image for you. Present day. Yeah, cool. Yeah. This is pretty, yeah. Vlad could see mañana. Yeah, okay, here's Colima Rift, Jalisco block right up in here. Yeah, here's Colima, here's the EPR, right? The Rivera Plate, the Cocos Plate, looking out to sea, looking south right here, right? The Rivera Plate's diving underneath the Jalisco. The Cocos Plate's diving underneath Colima, creating the Colima volcano. All right. You can see there's also a split, a crack. Whoa. Yeah. Interesting. Good stuff. At geologic composition, the core of the Jalisco block is the Puerto Vallarta batholith, a large body of igneous rocks formed in the Cretaceous period. I don't know how long. Cretaceous is a long time ago. I don't know. Rifting extension. Tepic Zacalaco Rift and the Colima Rift are examples of extensional features within the Jalisco block, indicating ongoing tectonic activity. Oblique subduction. The Riviera Plate subducts beneath the Jalisco block at an angle, contributing to the complex tectonic stresses and seismic activity in the region. The crustal block movement is considered to be separate crustal unit that is detached from North American Plate, moving independently due to the subduction processes. Landslides and erosions in the tectonic activity resulted in uplift influenced by landslide, causing significant erosions and shaping the river systems in the region. Jalisco block is a tectonically active regions in western Mexico, characterized by volcanism, seismicity, and complex interplay of tectonic plates. Its boundaries are defined by active rift systems, and its geological history includes uplift and deformation associated with the subduction of the Riviera Plate. Here, let's take a look at it. Introduction. Here we go. Here's the Riviera Plate, right? Here's the Jalisco block. Puerto Vallarta's right there, right? Colima's right here. Michoacan block is down here. Okay? So these are the areas we're talking about. Here's the Cocos Plate. right? Here's the rifting of the East Pacific Rise,
The
which is
Revilla Digital Islands out there, Gahito Islands, are on the Rivera Plate, which we talked about back a while ago. One of the episodes.
Right.
It's quakes even out there on the outer side of the Rivera Plate.
Yeah, I'm not sure what plate they are on, but I'm taking your word for it.
Yeah, because that's why they're there. Because it's on.
It's all calm until it's not. I know, right? And you can see on this image here.
And if you get sevens out there on the edge of that plate, look out, San Francisco.
Yeah. Well, we're going to transition into that right now as we talk. So, all right. As promised, we're going to, as we do with every one of our shows, we kind of go ahead and try to extrapolate all this information and kind of show you how these things are how they're moving. What's the evidence of things moving?
Yeah.
And our evidence is earthquakes. Earthquakes are proof that the plates are moving.
So basically, all these blocks in Mexico. So if you get a big quake down at the bottom of those blocks, so Maya, Chortis, Central America, it's going to make all these other blocks adjust, right?
Correct.
So they're going to come up from the bottom, which is what I think it does.
And it's kind of like what we're saying in all the times. We watch, when there's an earthquake at one spot, we watch to see where it's going. Why? Because it puts stresses on other blocks, other parts of the plate, other land masses, and when they're ready to go, they're going to pop. On this map, you hear 1973, 2003, 1995, 1932, 1932, and the Puerto Vallarta gap. Interesting that there's a gap in Puerto Vallarta on the batholith, of all places. What's a batholith? Well, basically a plug, a volcanic plug, I think. Kind of like the Idaho batholith. It's solid rock, right?
Granite.
Granite, yeah. Approximate rupture areas for the two 1932 quakes, 8.2 and 7.8. 1973, 7.6. 1995, 8.0. And an earthquake of 7.4. In 2003. 1932 events shown with a solid line, while the 73, 95, and 2003 events are shown with dashed lines. The Vallarta Gap shows the expected future rupture area offshore the Jalisco block. It's a quiet zone. What have you learned over 5 years what happens in a quiet zone? Well, look at Sand Point. Case in point, the last 8 we had.
From 2017 to 2022, you had that whole section from Chiapas all the way
up to Colima.
All the way up to Colima, get hit by quite big sevens.
Big sevens and eights, yeah. Vallarta has not hit yet. And I pray it doesn't hit when my dad's down there. Right. I got my neighbors down there right now. But, because I like to have my dad around a little bit longer. He's 80 years old, so come on.
Because Gulf of Cali can get sevens.
Yeah, and these blocks, right? When these blocks are done, they push on North American plate. Yeah, and it translates other places.
I'm just going to give it.
Go ahead, bud.
Examples right now, and then I'll talk about how it connects to Rainier, which is pretty wild.
Sure.
But I'll do that at the end. So anyway, I've been studying all the quakes down there by Guatemala City since it started doing all the crazy stuff there last night. Well, it's done this many times before, because there was in that same spot where it started swarming and quaking. I'm combining the words together. Squaking, I guess it's a new word. Doing both.
There you go, buddy.
So many things on swarms and squakes. Swarms and squakes. So I started looking at that, and I started going back, looking at big quakes in history that we know about near Guatemala City. And so I started looking back, and the earliest one they had information on in detail was 1717. There was one there. And in the place that's right next to where Guatemala City is now. So that was the Spanish chose the place right next to it. Begins with an A now. I can't remember the name. Right next to Guatemala City to the west. There, that was the capital city for many years.
Oh yeah. Oh, I'll get you right there. As we move down here to Guatemala.
Yeah, HU something, I can't remember.
Yeah, Atlan or something.
Yeah, it should be on the. I don't know.
Yeah, I guess it's got to populate. Villanueva, Santa Ana.
Begins with HU, I think, the name of it.
Okay, yeah.
It's right next to Guatemala City, but that was where the original capital of the Spanish Empire was for Guatemala. And so there's a big
Antigua, Guatemala.
Yeah, Antigua, yeah.
Yeah.
And that's where the capital was originally when the Spanish first came there. So in 1717, there was a big quake right in that spot. And they said, well, it knocked everything down, destroyed all the stuff. It was like 7.5. So they rebuilt everything again, like what Europeans do. And then the same thing happened in 1773, and it knocked everything all down again, everything the Spanish built. So they said, well, I guess we better move it to a new spot. So they moved it to a place that was a little bit farther away from it, which is now, they didn't call it Guatemala City back then, but that's what it's called now. So they moved it to where it is now because of those two big quakes in the 1700s. And so what they actually did was move it closer to the fault. But of course they didn't know about fault back then. So now where they put the new capital city, Guatemala City, is actually closer to the Montagua Fault, the North American and Caribbean plate boundary. So basically they put the new place in a worse spot, but they haven't realized that yet. But the problem is now, it's the biggest city in Central America. Guatemala City is now. Population as of now, 2025, is 3.4 million. So there's a whole bunch of people.
Yeah.
And they don't realize that it can go 7.5 right under their feet.
Right. And Pacaya volcano, which is right there in Guatemala City, erupted here, 2 years ago, and we watched it as the magma came down the face, destroyed people's farms, and they were crying because, it was sad.
So, I think they're paying more attention probably to the volcanoes and the other quakes, because it's been a while. There was a big one there in, what year was it? 76, but it was farther up the Montagua Fault, away from the city. So it caused quite a bit of damage, but it wasn't. And I think they said that it was 60 kilometers deep. So it was down deeper, so it wasn't as much damage. But these ones that happened in the 1700s and in 1917, in the same spot that I'm talking about, like right between Antigua and Guatemala City, there was like a whole big sequence of sixes, like multi-sixes. And that did a bunch of damage too. 1917 and 1918. So it started near the end of the year, and when these sixes kept going on into the first part of 1918. And 1918 is also when the end of the year is when we had the biggest San Jacinto quake. So I started looking all these up. I couldn't find, I could see on GIA, the Global Historical Earthquake Archive, what was happening in 1717 and what was happening in 1773, but I couldn't really find anything in California because 1769 is when the Spanish explorers came ashore in LA Basin area, and there was a quake that knocked them off their feet. So that's the first one they know about. So I assume there was probably other quakes around that same time, between like 1769 and 1773. That were happening up there. We just don't know what faults they were happening on. Man, I'd have to go like looking into each individual fault and find out when they figured out
Right, but it's beyond the scope of what we're doing here. Again, we're trying to do an overview of how the different blocks work, and show evidence that the blocks are still active by revealing the earthquakes and what happens after an earthquake. Most people say, "Oh, just one earthquake, bang," or aftershocks, bang, and it's all done. No, everything else gets moved, and it's because the plate is moving, and it moves with the evidence of the plates moving is the earthquakes. The earthquakes themselves are not what's moving the plate.
Yeah, and in those quakes in the early 1900s, all the way to 76, I think it was the latest big one down there. You can see that afterwards it went right up, like from Guatemala going right up, and you could follow it the next year. It went right up and hit like SoCal, hit NorCal, and then it would hit up Vancouver Island. And that's what it did after they had like the bigger quakes down at the bottom, which I've noticed that with a bunch of all the other things. So it's like the same pattern repeating. So then I started looking in the ones that are off the coast of Honduras on the Caribbean North American plate boundary. So the ones there that are out the Swan Islands Transform Fault. So I've been paying attention to that because we had the big Caribbean quake down there in February this year, February 8th, that was on that Swan Island Transform Fault off the coast of Honduras there. Well, that's that same plate boundary that comes into the Montagua, Polochic, whatever, that whole fault system is the Caribbean North American plate boundary, and it's the one that comes in right by Guatemala City from the Caribbean. So I started looking. Well, we actually did a rabbit hole on the Swan Island ones back a while ago. Well, since I've been studying all those ones down there to see what happened afterwards, well, just the last couple days, everybody's been freaking out about the Mount Rainier thing. So I've been watching all the Mount Rainier swarm information because I watched the interview that a Seattle TV station reporter did with the USGS lady that runs all the seismos on Mount Rainier. And so she was explaining like what they have up there for instruments and all that stuff, and when it last swarmed in 2009. And I said, 2009? Why does that sound familiar? So she gave like the dates, what it was doing, how many quakes, and it's basically doing the same thing now. It did 1,000 quakes back there in 2009, and it's doing the same thing right now. The one in 2009, that lasted, I think, for 3 days, and I don't know what it's on now. The one now, 2 or 3 days, I think, so around the same thing.
Yeah.
So it did it back then, but then I said, well, why am I remembering 2009? So I looked back in my other stuff, and I said, there was a high 7 down there in the exact same spot in 2009 that we just had back in February. So I looked it up, and I said, oh, well, that was in May, and the swarm in 2009 was in September, so it was like 5 months later. And then back at the other one, the quake we just had in the same spot down there, and I said, well, that's the same spot, and it was like 7.6, whatever, 7.5 in the same spot, and it was in February, and I said, well, that's like now Mount Rainier shaking again. So I said, well, that's weird. Like, it's once there's a big quake in that spot down there, and it's twice in a row, Mount Rainier starts, and it's like 5 months. So it's like 5 months between the 7.6 at Swan Island Transform Fault down there in the Caribbean. And I said, that's friggin' weird. So I'm saying, is there some weird connection now between the Caribbean North American plate boundary and Mount Rainier up there shaking? Because that's kind of odd that it would do it like exactly same size quake, same size spot, like the same amount of time apart. So it's like it was making its way up there, working its way up to the north before it shook. Now I'd have to look back and find out how long they've been monitoring the swarms on Mount Rainier. I don't know. Like if it was doing the same thing like back in 1980, because there was a big quake down there in the same spot in 1980 too. So the same year as all this, as Mount St. Helens was acting up, and see, Mount St. Helens has been acting up too, which I just realized that now.
Yep,
So,
I showed that this morning on the morning report. Morning report is on twitch.tv/Joe Slick Live Monday through Friday, 8 a.m. Arizona time.
Yeah, if there's some crazy connection between all of them. Because now I'm going to have to go back and look and see what each one of those places was doing. Because now that I know a bunch of dates for the Swan Island transformed fault quakes down there off the coast of Honduras on the North American plate boundary, is there some weird connection that's making the volcanoes act up after there?
Very well could be, bud.
With Rainier, but now it may have stuff to do with the other ones too. So it's crazy stuff. 76 was the big quake that was up the fault from Guatemala City. So that's getting pretty close to 1980, right? So that whole fault being active going across the Caribbean. So now I'm going to have to go look and see if other things were acting up back then too.
Well, you know what's crazy too is I finally found the date it was created, but I was looking through it. The Rio Grande Rift is the rift I was talking about that splits North America. The southern portion of the Rio Grande and south of Albuquerque, north of the border, right? Because they stop it at the border. They don't know why. America's the way the Americans write. It actually goes further south into Mexico. The older is closer to Mexico. As it goes north, it gets younger. That would suggest there's a progression. And the older part is 35 million years ago.
Yeah.
That's pretty far out. And, so all the dates are starting to coalesce. Saying, hey, something big is happening, and I wanted to jump that in. But I don't know how many earthquakes or not. Yeah, they're earthquakes. They're not just vibrations in the Pacific Northwest.
Big ones, the ones that hit Guatemala City are like 7.5s.
Right.
So it can get really big ones right there because it's the plate boundary. Even inland.
Plus.
That's not talking about the ones at the coastline.
Right. And today there are vibrations now. Salem, in Oregon. There are 45 vibrations in Salem and in Roseburg. But in the volcanic seismicity, Rainier, I'm going to share it with people. This is the swarm that the internet is abuzz with, right? So I'm going to pick out one of these. It's up in the mountain, about a third of a mile. So it's up by the surface, up tenth of a mile, up a seventh of a mile, meaning above sea level. Okay, everybody.
Yeah, I went and looked up in 2009 if there was any notable bigger quakes in Washington.
Up in a mile and a half up from sea level. So a half a mile below sea level. So these are the number of I don't know how many. I can't count them all. I say 100 over the last 7, 8, and 6, 17.
Yeah.
So the last 2 weeks, 3 weeks, there's been 100 earthquakes on Mount Rainier. If I looked over here at St. Helens has, got a bunch of earthquakes. They're all this month. 628, actually. 628 to 610. Right? 7, 8. So from yesterday all the way to the 10th. So it started in St. Helens. And it's also now infected Rainier. Several hundred earthquakes on both of these volcanoes. People are saying, fear mongers are saying, "Oh, it's the end of the world." Well,
it's done it before.
It's done it before.
About Mount Adams, if it's been doing anything.
I looked at Mount Adams. There was nothing, but I'll look for you. Yeah. We'll go look on the seismicity. No image previous.
The smoke's down.
Yeah, there's no. It might be down. Yeah. Looking at St. Helens again. I'm wondering. I'm gonna go ahead and look at the seismogram.
Well, what's interesting, when it swarmed in 2009, it was September.
Look, you're there. Hey.
Is it working?
Do you see that?
Yeah.
We have to see if there's a storm over there. Okay. Here it is the day before. Right? July 8th. Now today, look at that. That's a lot of noise. Also, we have vibrations happening today in Oregon. I'm going to go ahead and look over on
see if there's a storm
on Rainier, and I will. I'll see if there's a storm. Okay, it's not affecting Rainier right now. Okay, let's go ahead and look at another seismogram, Rainier. How about the backside? Yeah, not affecting it. The western side. All right, so right now it's brand new. It's affecting St. Helens. Let's go ahead and look at COD. There's no weather. None. Global, let's go ahead and look at the west, see what's coming. It's a high pressure. High pressure over that portion of the country. Right, so let's go ahead and look at the dirty. Look at the upper level, lower level. It's all hot. It's freaking hot, actually. Look at Windy, what Windy's got to say. See if there's a gusts of wind that are knocking the mountain around. Wind speed.
So right now, I'm more worried about Guatemala City getting that 7.5.
Yeah, I agreed.
Cascade volcano.
Yeah, it's nothing. It's way up there, up 30,000 feet. That's normal. At 5,000 feet, 16 miles an hour. It's not affecting it. That's a vibration, a genuine vibration in St. Helens. Looking at Guatemala.
About 2009 is that was the end of 2009. Well, early 2010 was the Baja set point too. 2009, 2010 was the Baja. Yeah. Yeah. So it
was it the end of 9?
Yeah, September 2009 is when the swarm was at Rainier.
All right. Yeah, and that other one happened on Easter 2010.
Yeah, so the early
part of April.
So yeah. there was a big quake in 2009, 7.6, 7.7 down in the same spot. We just have
all right, and then the other one was a 7 central Baja, California. There's volcanoes over there. If you didn't know, in that portion of Baja, excuse me, in Baja. I'll show you here. I was doing a research all day on different.
I got to look up what the date was on that. I think it's May.
Right in here. The Jaguar volcanic field is right here. Coronado volcano was right here, right? And I believe that earthquake was just down a little bit more. And I could do a research. 2010. Baja quake. Yeah. Well, actually, it shook my place. So yeah, it was in the Delta.
Yeah. So the 2009 Swan Islands earthquake was May 28th. 7.8 8.3 in the same spot we just had the 7.6.
When was the Calexico earthquake? Like 1930s or 50s, right?
I don't know. I don't remember.
Big earthquake in Mexico. Just
Mexico.
Earthquake.
Exact date.
Maybe it'll just give me. I'll go to the wiki. Large earthquakes in Mexico. Here we go. 2000. Oh, way back here. Guerrero, Oaxaca, Baja California, 6.4, 79. No, it was in the 50s, I thought. Baja, 1890. Nope, I guess not. Maybe they call it California earthquakes. I'm gonna do another search here.
Or it has a different name.
Yeah. It's El Centro.
Oh, El Centro quake.
Yeah. Dun, 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 1940. All right.
Oh, yeah, yeah.
Let's look at 1940 earthquakes. All right.
What time of year was it?
May. List of quakes 1940. So we can go back to 39.
Yeah.
See if anything's in Baja. Oh, okay. By magnitude, I'm not going to worry about that. There is one in Mexico. Gulf of California, 7.
Well, that would make sense then.
1939, yeah. Guatemala, off Guatemala, 6.5. In January. Off Guatemala, 6.5, January.
Yeah, well, that would make sense then.
Yeah, right. 8.3 on Chilean earthquake, 1939.
Yeah, so see, it would be the same thing.
Yeah.
8.3 and working its way up.
Yeah.
Yeah, so that would make sense.
Honshu and Kyushu were both rocking and rolling at the same time.
Yeah, I'd noticed that.
I think it's intrinsically connected. I don't know why, but Japan and Mexico, Gulf of California had a 7.0.
And probably Crete was going off.
Sea Cortez.
What happens?
Yeah, watch Greece, right? Costa Rica had a 6.5. Yeah, going into August, Alaska, of course. Greece, 6.5. Ionian Sea. Ionian Sea is rock and rolling right now. Guatemala, 6.2. Japan Honshu's got a 7. It's Costa Rica 6 in on October, November, nothing. December, Guatemala again 6.7. Guatemala rocking and rolling in 1939. Costa Rica has a 7.3, a 6.8. El Salvador has a 6. And then we go on to 1940. Remember the El Centro, everybody. We already have Guatemala. We already have Peru. We already have Costa Rica and Baja already. All 7 pluses.
Guatemala shakes. It's not good for SoCal.
No, it's not. All right, January. Okay. Nothing there. Alaska, 6.8. Greece, 6.0. Freaking Greece. I don't know why it's connected. Chile 6-0. April. Alaska's going off. A couple of sevens.
Mendocino limit goes all the way to Greece.
Yeah, it goes underneath. Yeah, everything slides on it.
And if you go across,
May.
it goes Sagami Trough under Japan. So that's why Japan's always acting up.
Southern Cal 6.9. El Centro killed 9 people in May. All right, so
I wasn't looking for that one, but we found the Guatemala connection to it.
yeah.
I'm not surprised.
All right. And so there was Guatemala, there was Salvador. Didn't see really any Mexicos, but except for Baja and Peru. All those were the largest quakes. And Peru, at the same month that California goes off, comes back with an 8.2 and a 6.6. The Lima earthquake of 1940 killed 180 people, injured 3,500. That's
what we're actually doing now is the lead into all the stuff we did before that was 43 to 46.
Correct.
Actually, yeah.
And Canada, Northwest Territories had a 6.2 as well.
Yeah.
And all that happened in May.
6 and above, you're in trouble.
And then again, the Gulf of California, 6.2. Mexico. Northwest Territories again, 6.5. Hawaii ended up with a 6. Hey, man, Hawaii, I watched the earthquakes today happen, and I watched dramatic difference in the elevation of that fountain going off today. Yeah. It started kicking out a lot more gaseous stuff, and then it just died out like an hour later. I watched like 3 or 4 earthquakes go up. Watch the camera, it's moving. In July, Rat Islands, Guatemala again, 6.5. Sea of Japan had a 7.5. Wow, tsunami.
Oh, I know Kilauea is usually acting up when there's bigger San Francisco quakes.
Yeah.
So it's probably the same.
Also, Southern Cal, there's the triangle, man. Fox Islands, Peru, 6. September, Chile had a 6.5.
I wonder if Colima was doing anything.
Brazil had a 6.0, and so did Argentina, 6.5. Right. Argentina 6.2. Oh, I don't know. Chile 6.5, 6.2, 6.9. Freaking Chile was banging in 1940. 6.4. Kenai Peninsula had a 7. Chile come back with another 7. Ecuador had a 6. Chile comes back with a 6. Costa Rica 6.6. That's all in October. Honshu, Japan had 6.7 in November. The December, Baja California another 6.1. Bolivia 7.1. And the Marianas again 7.7. I think the Marianas are attached to Japan, and I've been showing evidence of that. Every time we do morning reports. Interesting. Very, very, very interesting on the movement of earthquakes. Now, volcano eruptions, 1940. All right, let's see. Hawaii, Big Island, Mauna Loa. 65 to 200 feet. Look at that. Oh my God. Mexico, Paricutin volcano, which began eruption in 1943, but events leading up were not as noted in the context of volcanoes surged suddenly from the cornfield of a local farmer. I just studied this today.
Yeah, so that was right. Same.
Attracting both popular and scientific attention, 1940. We're going to study that volcanic thing in Mexico next time around on Saturday. The Mexican volcanic, whatever it's called there.
Volcanic belt.
Santorini, Greece, erupted in 1939, 1941. Vesuvius, oh my God. Its last great eruption in March of 44.
Yeah, because now today they're worrying about Vesuvius. I saw a report.
Yeah.
So
Yeah.
now it's not just Campy Flegrei now.
No, it's Vesuvius. The whole complex is one big giant volcano. And when it erupts, a lot of people are going to die. Yeah.
So they're getting it from everywhere.
Crazy, man. Yeah, Santorini. Remember Santorini earlier this year? They thought it was going to erupt.
Yeah.
Well, guess what? 1939 and 49, it did erupt.
Yeah.
See, again, it's one of those things that you got to say, wow, is it just random or is it?
Well, that's the same east-west line going across.
Well, it's something, you know. Yeah.
All the way since the Turkey quakes a couple of years ago.
Yeah.
And Iran's due for a big one too. So,
it looks like Sangay erupted as well.
And when I started looking up all those ones that were going off before Nankai Trough in Iran, they were all in the same places where the nuke sites are.
Say that again?
When I started looking up all the quakes that were going off before Nankai Trough in Iran, or around like the year before, or whatever, because those mountains come the whole way across Iran, Tibet, and whatever the three, Burma, the whole way across there, that orogeny that comes across was all acting up in 1853 before the big double Nankai Trough quakes. And when I looked them up where they were, they're all in the same area that we did the Iran study on, because one was at Shiraz and the other one was, I can't remember the place, but when I looked up all those other years, it was getting like big quakes in Iran, like the year like around the same time that Nankai Trough went off.
Yeah, Turkey had a big quake in 1939, killed 32,000 people. Valencia earthquake in Bucharest, 1940, killed 1,000 people. 41, Jabal Razia Sada earthquake occurred.
Day, I think it did.
Yemen, 1941.
Days ago.
What's that about?
Like, I think Romania acted up here the other day.
Yeah, Romania. It did.
Like
there was an earthquake. I showed that one. Yeah. Also, not Croatia. Yeah, Croatia had an earthquake as well.
Yeah.
So interesting.
Line that goes to Iceland. Basically.
Yeah. I mean, when you look at different things in history, and as we close tonight, when you're looking at them things, and you're seeing, okay, this event happened in this time period. This event happened in this time period. And we're talking very minute time periods. We're talking 1 to 2 years, spread. Yeah. And we're watching massive earthquakes go here to there, to there, to there. We're watching volcanoes here to there, to there, to there. We're watching events happening, weather events happening as well. We haven't got into that tonight. We've run out of time. We ran really good tonight, strong. An hour and 44, matter of fact. Probably about an hour and 40, to tell you the truth. But these overlaps of these different events, kind of far out, man. Kind of far out. I can look at floods. What is it? I don't see any in 1940. tsunamis. Yeah, nothing.
And what's interesting about the recent floods is they're all the same spots that the eclipse went over. So that doesn't bode well for here.
Yeah, because it went right over you, all right? Yeah. Yeah, crisscrossed.
Because where it went through in Texas was
the Texas lineament there, and then it went up the other lineament up your way. And we're both not in a really good situation, huh?
And where Chicago was getting pounded with rain last night.
Well, you know, I'll take my my aluminum foil hat off right now and say, you know, the only reason why we're picking up on this stuff is because it's in the signals of the planet, and we're in tune with it, and that's why we see these things and nobody else does. Okay, I'll put it back on.
So that means at some point this year, a hurricane should follow right up. Pathway.
Well, there's no tropical activity for the next 7 days.
But it rains here all the time anyway.
Yeah.
It's just a question of how much we're going to get. Or the other night, it was the apocalypse for half an hour.
And Timmy says we're crazy. Priming up for an 8-something. Could be.
Well, I think more mid-7s right now. Unless it's Nankai trough, that'll probably be.
Yeah, then there's a couple high 7s, low 8s. Yeah. Well, we'll find out, right?
Yeah.
I don't know why. It's got a freaking limiter on this shit. Oh my god. Anyhow.
Since space weather controls everything, but
yeah, right. Yeah. I have my hat on, so I didn't hear that. you know the big it's a tragedy what happened in Texas. Those people were all warned. They all knew they were in a flood zone. They watched the water rise. There's video of them watching the water rise. There's also
I read today they just had the disaster emergency management plan there approved 2 days before this happened. So I don't know what they were doing.
Yeah.
Apparently nobody was reading it.
Well, it didn't get disseminated to the people. I mean, I've seen a lot of not officials, but workers, firemen and the like. They're watching the water rise. They watch that torrent come down the pike during daylight hours. Those people who died in the wee hours of the morning, but
yeah, it was like 4 o'clock in the morning.
Right. There were people in their basements, and they were trying to stop the water coming in.
But they put the alert out at 1:41 because I looked it up. So if you had a cell phone, it should have been on your cell phone. But if you were sleeping, I guess much better.
Right. What about the day before? What about the day before? What about the stinking day before? They were watching the water rise. I saw videos where the people, the kids, you can hear them laughing in the background. They're watching the water rise, and it had timestamps. I posted it on Facebook. I'm just so incensed by it all.
Yeah, well, they didn't put a catastrophic flooding warning out to 1:41 a.m. They put flash flood warnings out earlier that day, but then it rained more than
they should have put watches. Flash flood watches.
Of course, for me,
and it's the same type of event that happened in the Carolinas. It's the same type of event that happened in Utah. The same type of event happened in Florida.
Well, it just happened
where the storm cell just sat there
yesterday too.
Right.
Where it took out of town
and it's the same type of event that wiped out the Chinese base on the island offshore of Florida. Okay, so I mean, I've never seen a hurricane stop. It stopped for what, 2 or 3 days, and it didn't move. How does that ever happen?
Well, that's what Hurricane Harvey did too.
Yeah,
years in Houston.
Just whatever.
Well, land too.
I think about it being my kids, and it just freaking kills me. You know, if you saw your nephew and niece, you know, that were in that situation.
Well, yeah, they wouldn't understand it. So it's up to the camp counselors and whatever
Right.
adults there to figure this thing out.
Right.
Which how am I? I'd probably be wide awake. I'm like a
Right.
rocket. I'd say, get out of here.
Well, now
And for the-
their line is underwater.
Oh, now Saunders said there's flash flood warnings for DC now.
For DC, yeah.
So the rain.
Tim is saying it's a full moon. He just sent me a picture of a full moon. I'll send him a moon picture.
Yeah.
Sandbag wasn't going to stop this movement. You can see the creek. It was dry, bone ass dry. One day, then the next day you can see like almost hourly pictures. And
well, some of the places have sirens, but they don't.
Yeah.
Didn't have them there. Which I thought.
Right, I heard one of them having the siren as well.
Yeah, the same thing happened in the 80s there too. Not as bad as what it did this time, but pretty close. So I don't know.
Well, Kat showed something on Utah, and I just quite literally couldn't stomach it.
Yeah, well, there was
You know,
a big flood there in the same area in Texas in the 80s sometime too, because I saw videos about that, and it was the same thing except they tried to get out of there. They got in the buses from the camp, but the water came in and caught the buses.
yeah, and this wackadoodle out there, that cloud seeding of the Texas sky 48 hours before. Somebody, you know, I mean, please, I still have my conspiracy hat on.
Yeah.
You know?
Well, I don't know, but these other places, there's not too many planes. Like, we still get flash floods here, and we don't got enough planes to freaking do anything here for cloud seeding and stuff. But we still get flash floods. So. And I don't know if they were cloud seeding back in '87 when the big flood came through Texas there in the same spot. So I don't know. So I don't know if it's cloud seeding or not. Could be, might be adding to it, but you still had flash floods in all these same areas before we were doing cloud seeding operations. I know in Canada they might do it in some spots where there's a lot of planes, but Canada's way too big. You need like 10 million planes to do cloud seeding here. There's way more in the States. And what we have is like radars. There's way more radars, Doppler radars in the States than there is in Canada. So they could try to do stuff with them, but I don't think it would accomplish too much. And I know the Germans are doing stuff over in Germany and France and all those places, and they fly down during hurricane season in the Atlantic and do stuff too. So, because it's all on Monkey Works, he follows all the planes, and they even say on the plane weather modification, whatever the name of the company is. So you can see where they go and everything and find out what they're doing. Because he was showing a bunch of the planes that were doing it over Texas. The few days. Well, he said that they've been doing it for 30 days. But he went in and showed the flight paths for like the last 7 days that they're like right over Texas area. Right where the flood originated from. But he showed other places they're doing it all over. They were up by Chicago too. Which then they had the big flash floods there last night where the storm stayed right over the stadium and it rained out the game. And it started like it was nothing, and then it turned into this big gigantic.
Well, I'm going to show the time lapse here, so I'm going to go ahead and go off of YouTube and off of Rumble. Big hugs to you, everybody. Again, joeslick.tv/joeslicklive. Actually, it's twitch.tv/joeslicklive. I don't have the Joe Slick TV yet. I will. It's in the process. But
I think limits have to be charged too in order for all
right.
This.
Well, that may be part of it too. So for those on YouTube and Rumble, you can find us over on twitch.tv/Josic Live. There you go. Love y'all. Thanks. And look forward to seeing you on Saturday.